They are a one-way street. You go in, nothing escapes, not even light. In Sagittarius, there is a black hole that weighs 2 to 4 million times the mass of our Sun, and we on Earth are actually moving around that black hole. If you thought you knew what black holes are, prepare to have your mind blown. There's just no good end to anything that falls into a black hole. There's a lot more that happens in those things up in outer space, and fascinating new details are being revealed to this day. More recently, researchers in Russia have made some of the scariest discoveries ever. Join us as we unravel what Russian scientists discovered inside a black hole that terrified the whole world. Black holes and how they form have long been subjects of intrigue. The common, more fictional concept of black holes is that they're some sort of portal to another dimension. This has been proven wrong many years ago, and what scientists have discovered may send shivers down your spine. According to researchers at NASA, black holes are mysterious entities of space with a gravitational pull so strong that even light can't escape. Something that scientists thought was impossible turned out to be true in 1915 when Carl Schwarzschild found the solution to Einstein's equations predicting the phenomena of black holes. But it wasn't until later, in 1964, when Cygnus X1 was discovered, that something which was just a theory turned into a physical entity that revolutionized astronomy. Cygnus X1, this special black hole, is 15 times heavier than the Sun. It also has a companion star for easier identification. This binary star system is a very strong source of X-rays and is considered the first major evidence to prove the existence of black holes. It sits approximately 7,000 light-years away from us. The fact that scientists discovered something so far away in the early 20th century is by far the most interesting thing. Fast forward to the 21st century, we've discovered over 100 million black holes within the Milky Way galaxy. Since these things are invisible and a lot bigger than the Sun, their existence is a terrifying thing to consider in the cosmos. Now, the question that was on every researcher's mind was how these things form in the first place. Since there's no life, gravity, or air in outer space for basic chemical reactions to occur, how do black holes appear in the universe? There are generally two pathways that scientists have studied: stellar corpses and direct collapse of gas. Stellar black holes are born from the remnants of massive stars that slowly lose all their energy and collapse under their own gravity. Direct collapse of gas, on the other hand, can lead to the formation of more massive black holes, most of which are supermassive ones. There are two different pathways after gas clouds collapse under their own gravity. The first pathway of cosmic evolution begins with the life cycle of a massive star. The initial masses of these kinds of stars are around 8 to 10 times that of the Sun. When stars shine brightly, they fuse hydrogen into helium in their cores. Once the nuclear energy finishes, it collapses and triggers a catastrophic event known as a supernova. Here, the outer layers of the star are released into space in a violent explosion. And because it's outer space, where you can't really hear anything since sound can't travel there, these supernovas could happen without you even noticing it. Once the supernova occurs, one of three things is formed: either a neutron star, a white dwarf, or, if the star is massive enough, a black hole. Believe it or not, if a supernova occurred as far as 65 light-years away, the cosmic rays and aftermath would risk humanity as we know it. At least 30% of the ozone layer all around the planet would be completely destroyed. 87% of it would be destroyed in polar regions. Coming toward the second pathway, the direct collapse of massive gas clouds skips some of the stages of star formation. In regions of space with high densities of gas and dust, different gravitational forces can cause clouds to collapse as well. The difference here is that a protostar is formed. In some special cases, the gravitational forces are so strong and intense that even a protostar isn't formed. Instead, the gas cloud collapses and directly forms a black hole. Another question that's often asked is how long these entities last. Do black holes lurk in distant galaxies forever, or do they eventually die and leave something much more terrifying? When they form, they can live for potentially billions or even trillions of years. Their gravitational pull has been felt at every corner of the universe for a very, very long time. With this pull, they draw close gas, dust, and even stars. These things are usually drawn in groups and clusters, which eventually form a disk. So what happens when the so-called disk exists? Think of it like a Death Star that shoots high-energy radiation like X-rays and gamma rays. But that's what happens to the things around the black hole, right? What happens to the actual black hole? Many scientists believe that black holes are considered to be eternal. Once they're formed, they'll exist forever. The only thing that slows them down or makes them fade away is the emission of all those gamma and X-rays from the makeshift Death Star. Stephen Hawking helped coin this theory in the 1970s. Hawking radiation was named after a brief quantum study of black holes. As the Hawking radiation is emitted over time, the black hole slowly loses mass and eventually dies. Let's talk a little more about Hawking radiation to get a clearer picture. These come from quantum fluctuations near the event horizon, where pairs of particles spontaneously pop into existence. To make things simpler, think of these particles as bubbles in a fizzy drink. They appear out of nowhere, completely unpredictable. They also come in opposite pairs called antiparticles. When they meet, they cancel each other out and disappear forever. It happens so fast, it's as unpredictable as them appearing in the first place. Sometimes they'll appear on the event horizon, and if one of them falls into a black hole, the other escapes into space because of strong gravitational forces. The one that's trapped in the black hole, though, has some of its energy stolen from the void itself. The stolen energy piles up, which causes the black hole to lose its mass. In a nutshell, this process is what we call Hawking radiation. So black holes aren't just for swallowing anything within their vicinity. They also release this Hawking radiation. The phenomenon helps scientists understand the lifespan of a typical black hole. The smaller the mass, the more rapid the Hawking radiation, and the shorter the lifespan. It also helps scientists differentiate between black holes and wormholes because these two behemoths of space aren't as similar as one may think. The concept of black holes and wormholes is intriguing. Unlike black holes, which are regions of intense gravitational force, wormholes are hypothetical tunnels in space-time that connect two distant points. Now, this may sound very fictional, something you'd see in movies or read in storybooks, but scientists are trying their best to figure out their existence, and they seem to be making breakthroughs year by year. It all dates back to Albert Einstein's theory of general relativity. Scientists have been studying these things since what feels like the dawn of time. Einstein published his theory in 1915 and expanded it 10 years later. His theory suggested that relativity argues with the concept of space and time being unrelated to each other. By definition, a wormhole is considered to be a tunnel from one place in space to another. If you were to place an object in space-time, it would create a curvature of the space-time in the nearby region. This theory has been used in many science fiction movies, but the problem is that scientists have never proven its existence. Black holes, on the other hand, have been found and photographed using event horizon telescopes. The theoretical entry of a wormhole is two-sided. Again, they are similar to tunnels with one way into a different point in space-time. Black holes have an event horizon. This means that if something enters this region, it's stuck in the black hole for eternity. The only similarity between black holes and wormholes is the influence of different masses. The mass of the object affects the size of the curvature in space-time in the case of wormholes, while it affects the energy released from black holes. NASA might end up making a telescope specifically for wormholes, just like the Event Horizon Telescope. This depends entirely on how technology will change in the future. We've already launched a telescope that can basically turn back time. Yes, the James Webb Telescope has made some very interesting discoveries that will blow your mind away. The possibility of an image of a wormhole would change the course of astronomical sciences forever. But as far as space discoveries go, wormholes are unfortunately out of the question. What was discovered, though, is something that blew away many scientists all over the world. But before diving into the specifics, you should also be familiar with some of the black holes that have already been discovered. The first black hole captured, Messier 87, also known as M87, is probably one of the most interesting discoveries made to date. It's actually a supergiant elliptical galaxy in the constellation Virgo containing trillions of stars. It's also one of the most enormous galaxies in the universe. 55 million light-years away from us, M87 also emits radio waves in the universe. It's no wonder why astronomers are enchanted by something so magnificent. It was first acknowledged by Charles Messier in 1781. The technology of this era was almost non-existent to make any detailed observations, so M87 wasn't fully understood until much, much later. 2 centuries later, Heber Curtis observed a jet-like feature in the core of M87. This was the first identification of an extragalactic jet. What's an extragalactic jet? It's like a stream of radiation emitted from the center of a galaxy. And what's one of the main causes of radiation like that in the middle of nowhere? A supermassive black hole. The extragalactic jet extended over 5,000 light-years from the core, which only gives a rough idea of how big and powerful this black hole is. This is why it's called an elliptical galaxy. M87 has a relatively smooth and insignificant appearance compared to other galaxies like the Milky Way. The actual size of this thing is about 120,000 light-years. Keep in mind that the number of miles in 1 light-year can't even fit in a calculator. The black hole of the elliptical galaxy is actually called M87 star. To put things in perspective, the mass of it is 1 billion times more than the Sun. It wasn't until 2019 that the EHD captured the first ever image of the black hole. It revealed a silhouette of M87*S event horizon. Not only did this image mark a significant breakthrough in scientific research, but it also proved the existence of supermassive black holes. Einstein's theory of relativity's predictions were slowly being proven. Yes, this also means that a wormhole is highly possible. On a different note, the fact that M87 and its black hole act like an atom has bothered some scientists. The black hole acts as a nucleus and influences the surrounding stars with its gravitational forces. The universe might as well be acting like one huge atom. This could only mean that there's an even bigger black hole out there somewhere with a mass beyond our imaginations. Maybe it influences other regions of space similarly. Black holes too. Once you see what a colored image of a black hole looks like, the thought of something even bigger would terrify you to the core. Sagittarius A*, one of the supermassive black holes that lie in the heart of the galaxy, is known as Sagittarius A star. This thing is 4 million times the mass of our Sun and is about 26,000 light-years away from Earth. The gravitational pull on this thing is beyond our imagination, which is why it has a huge influence on the many stars and space dust around it. Black holes may be invisible, but they trap light to the point of no return. On May 12, 2022, researchers over at MIT found a way to capture the light around the supermassive black hole and reveal an actual image of Sagittarius A star. The researchers used an event horizon telescope, which is a group of radio telescopes located around the globe that function as one unit. The details that were revealed about this entity terrified many researchers and astronomers all around the world. Sagittarius A* was captured in the form of a glowing circular ring of light. The ring structure is at a point beyond which light cannot escape, which is because the light is bent by the black hole's intense gravity. The ring circulates around a dark center, which is Sagittarius A's shadow. The hot plasma in the ring is about 10 billion Kelvin. That's 1 million times hotter than the Sun. But the story behind this black hole is an interesting one too. In April 1933, Carl Jansky discovered radio signals from a location close to the constellation called Sagittarius. Now, in the early 20th century, when the internet wasn't even a thing, this was a huge discovery. They named the radio source after the constellation. Since the technology was very limited at the time, it took a few more years of observations to show that Sagittarius A had many bright and compact components overlapping one another. In February 1974, they added the asterisk to the name because of this new discovery. Scientists realized that Sagittarius A* was a black hole by the 80s and the 90s. Sagittarius A* was tightly concentrated and on the order of close to 3 million suns. Recent observations provided researchers with colored images of the black hole, but when the James Webb Telescope hit the market, everything changed forever. What did the James Webb Telescope find? Being one of the most powerful colored telescopes in the world, there must have been a major discovery that had everyone on the edge of their seats. In 2023, the James Webb Telescope spotted the oldest black hole to ever be seen. This thing had a mass 1.6 million times the Sun and has been in the universe for the past 13 billion years. The thing with this telescope is that it can determine an approximate date of when something in the universe existed. This black hole was present in a galaxy far, far away called GNZ11. It formed 440 million years after the universe began. So just to be clear, the black hole was seen as it was 13 billion years ago. There are no clear images of what it looks like today. With the help of this new telescope, scientists had another factor to consider in their theories. They may be looking for some of the comparatively newer black holes in the universe, but failed to consider the more ancient ones. But here's the scarier part about this discovery. Apparently, it's eating its host galaxy by devouring stars and other material to help it grow. No one knows if this thing has moved in 13 billion years, but if it has, who's to say that it won't reach our solar system in this lifetime? What's significant about this black hole is that it has a very big mass to be so ancient. It's also very unusual to see a black hole so old in a galaxy so young. Yes, GNZ11 is only a few 100 million years old. With this discovery, a lot has changed for astronomers. Many scientists and researchers started to rethink how black holes are formed in the first place. Earlier galaxies are gas-rich and have a ton of stars in them, which would be an all-you-can-eat for the average black hole. This ancient black hole behaved very differently from other old black holes that have been discovered. For starters, this one had a larger appetite for what to feed on to help it grow. Some scientists think that it's eating a bit over the average limit. If it continues to overeat, it'll start pushing the gas away from it instead of swallowing and collapsing it. This may not be a threat to us, but it's a threat to GNZ11. The gas that's getting pushed away is in the form of strong wind. This isn't your average breezy weather, by the way. It's more like gusts of wind if the Earth spun 1,000 times faster than it does right now. This strong wind would affect star formation and its delicate process. The destruction comes full circle because if there are no stars formed, the black hole will have nothing to feed on and will eventually lose its power. This is another discovery made about how black holes die at some point. But it all goes back to the question of how the black hole was formed. GNZ11 is still young and is around 100 million times smaller than the Milky Way. The current understanding of black hole formation states that it should take around 1 billion years to be as big as it is today, but both galaxy and black hole are only 400 million years old. What caused it to get this big? Astronomers find themselves with a new challenge all thanks to the James Webb Telescope. They also believe that they'll be able to find even older ones in the universe. To think that technology has advanced from Galileo's telescope to the James Webb Telescope is something worth admiring. Clearly, this discovery was just the beginning of what's more to come. But because of more recent observations, the new beginning is a little too bright for our liking. It's actually very unnerving. The biggest and brightest black hole to date, as compared to the ancient black hole that the James Webb Telescope helped find, astronomers also found a monstrous entity that devours a star every day. Scientists have called it the most hellish place in the universe, but it's nothing to worry about because it resides 12 billion light-years away from us. For something as terrifying as this, how much would the mass be? Take the sun's mass and multiply it by 17 billion. For something that big, it'd need a good diet, wouldn't it? Well, upon closer observations and calculations, it was revealed that the star that this thing eats on a daily basis is actually a sun. The name given to this black hole is J0529435107. It is 15,000 solar systems long. Even the thought of it gave scientists the shivers. This hungry thing is known as an AGN, or an active galactic nucleus. This means it's very energetic and will devour anything in its path. With that, researchers realized that advanced telescopes pose more questions. First, it was how black holes are actually formed after the most distant and ancient one was discovered. Now it's how something this powerful exists in the universe. This only meant that our understanding of the cosmos is unbelievably low. If you fear that this hungry monster is a threat to humanity, then think again. It's 12 billion light-years away from us, meaning its ray of light would take that long for us to see it. It also means that the black hole would have stopped growing a long time ago. This is the crazy part about space observations. Since the universe is about 13.7 billion years old, the light that was detected from this fiery black hole means that what we've observed was something during its adolescent stage. Being devoured by any of these black holes should be the least of Earth's worries. In fact, there are a specific group of black holes that actually face our planet. We've learned that black holes emit powerful bursts of energy, so shouldn't we feel a surge at least once? Well, these particular black holes are still very, very far away from us. In this case, the bursts of radiation are called blazars. The black holes don't really swallow as many stars as compared to other black holes in the universe. Researchers say that the jet or stream of light is directed toward Earth but are received as negligible faint signals. The energy in these rays is equivalent to the amount of energy needed to melt a snowflake. So even if something as dangerous as a black hole is staring right at us, there's absolutely nothing to worry about. If, in the off chance, we're swallowed by one, it's a scenario that scientists fear the most. Nothing survives inside a black hole, so just expect to be crushed in the most gruesome way imaginable. What are your thoughts on the wondrous black holes of the universe? Let us know in the comments below. Be sure to leave a like and hit that subscribe button to see more content like this.